Good afternoon, everybody. Good morning, good evening, wherever you are. Thank you for joining this TDL webinar on AI security. We have a great panel lined up. This session is being recorded. The recording will be made available early next week, probably, if not sooner, as well as a short written summary. If you have a question, anyone in the audience, you can put the question to the panelist and the moderator, who is Claire Vishik, a TDL strategic advisor, will bring it up and discuss it with the panelists. And with that, I'd like to hand over to Claire, who will take us from here and introduce the panel and take us through the next hour. On to you, Claire. Thank you.
Thank you so much, David, and thank you to TDL for hosting this interesting discussion. AI security is a very serious issue today. It's not a new issue as machine learning-based artificial intelligence started to be introduced and started to grow quickly. There were initial concerns about security. They were somewhat limited to the plethora of traditional IT threats combined with some specific attacks like adversarial attacks, like the need to protect models, which, by the way, seemed quite exotic even 10 years ago. Now that everyone is using AI, it's the driver of the high-tech economy. Security and some aspects of technical privacy associated with security issues has become as important as any issue gets. And a lot of new threats are now understood, realized in the labs, and unfortunately frequently realized as real attacks. They range from issues such as data poisoning, more traditional attacks such as adversarial attacks, to new attacks such as the one described for chat issues, for instance, in the open clause issues that was discussed recently everywhere. And today we have an outstanding panel to discuss what AI security is, how AI security is going to change the technology, what the most serious issues are, how is AI used by the defenders and, of course, by the attackers, and a lot of other AI security-related issues as well. We are very fortunate to have a wonderful and diverse in terms of expertise panel today. We have Kaleho, who is with LogicRiver, working on Agentic AI and consulting on AI security. We have Jason Martin, who is Director of Adversarial Research at HiddenLayer. And I should probably mention here that Jason was the person who introduced me to this topic, well, at least 10 years ago, when the inventory of likely attacks was pretty small. Thank you for that, Jason. We have Matthew Rosenquist, who is CISO and security strategist and founder of Cybersecurity Insights. We have Marcel Venandi, who is senior expert cybersecurity architect at Eon Digital Technology and is responsible for AI and AI security in that company. And finally, we have Rupert Young, who is the Chief Product Officer of MaxMind. We will start this discussion with each panelist introducing the state of the art for them in their area of the topic of AI security. What is important, what is essential, how this topic is going to develop, and other issues that you would like to include in this brief introduction. Rod, would you please start?
Yeah, sure. Thank you, Claire. I have been in identity security, for a long time, and more recently focused on identity. And as we get into looking at agentic AI in particular, identity has become, one of the focal points and one of the areas of my strategic focus on enabling agentic AI, swarms, et cetera, and particularly in the development arena to be completed securely. So that's been my focus for some time. And then, obviously you can't ignore the rest of the ecosystem because it's quite expansive. Thank you.
Um, Thank you. Thank you very much. What do you think has changed in the topic of AI security with the introduction and very quick adoption of agentic AI?
Security has always had a few different enemies that it's continued to fight, and I think AI, agentic has just made that worse. Those are, complexity, speed, and visibility or observability. And those are being pushed to the limit now, and challenged every day. So, some of the things that, we spent a lot of time in the industry working on secrets management, on all those things. And now we're seeing a lot of attack vectors hit API keys, our secrets, tokens, different things like that. So that's been an area of concern, in particular for me. I think one of the other concepts that's been interesting in all this is that, if you have, an endpoint that has endpoint detection, some type of anti-malware solution running on it, it's looking at what's on the disk, it's looking at what's in memory, and to different varying levels of efficacy. Now with AI, and what we're seeing is, that compute environment, you now have compute taking place in one area, memory, being, totally different. And you can have local storage, but then you also have vector databases and everything, which kind of breaks up that visibility again. So that's been interesting. And then, context between those different areas. And then, finally, the one thing that can't, be ignored, and that many companies, organizations are struggling with right now, is the advances in deepfakes and, some of the bypassing. Traditionally you've relied on something that you are, as a factor, and that's been continuously eroding over time, and challenging, and pushing organizations to look at that particular element in very different ways, and to scrutinize it and build additional controls and detection methodologies into that.
Thank you very much. That certainly is true. There is always a significant incremental component when new threats develop for a new area, and you covered them really well. Jason, you are the person who discovers the attacks, and probably also look at mitigations. What is your view on the field? What is happening?
Yeah, it's been interesting. As you mentioned, I've been in the field for a while, 10 years or so. And I think it is very interesting to see it evolve. And it was this very slow, like steady, people like myself and some of the other early security practitioners warning of what was coming. And then all of a sudden ChatGPT happened, and then it started to ramp up. And now the agentic is like, I didn't think it could get any steeper, and it got, even steeper, right? With adoption,
Yes.
as well as the blast radius of what's occurring if something goes wrong has dramatically changed. So I've been spending what feels like an eternity of about 1 year now, primarily studying in the agentic space, what I think of as agents through the lens of an insider threat, which I think is a more useful way to think of them than to think of them as a piece of software, because it brings into focus a lot of what traditional cybersecurity has done to manage the risk of human attack vectors. It's very interesting to hear Rod talk about identity, which of course is something that is getting very murky with agents who are acting on behalf of users rather than having their own identity. But we're seeing things happen like uh, the agents are the attack vector. There's this kind of attack that we've heard of called indirect prompt injection, where the data that's being ingested by the agent is the method for exploitation. So text becomes, a piece of malware essentially. But we're also seeing the agents become part of the payload of what is being deployed once the attack vector has been exploited. And that's interesting because a traditional payload of something like Metasploit or any of those sort of frameworks is very static, very like known ahead of time, whereas a payload of an agent can write its own software on the target platform to exploit whatever its objective is and then execute it. So I think that shift towards it being a payload as well as the attack vector is something that's very important. And we did some OpenClaw research recently, but that agent as a payload was just exploited in some research done on the Klein coding agent, where the attack vector was a prompt injection and the payload was OpenClaw. So I think that shift needs to be encompassed by the industry as well as the defensive mechanisms, because I'm very concerned about the impact of agentic botnets.
Yeah, it's impossible not to be concerned about it. So after years of building autonomy into artificial intelligence, we ended up in a situation where there are agents monitoring other agents. How does that affect security?
Yeah, I think number one, the agents, the models behind the agents are all vulnerable, regardless of what use case they're being put to. And so the agents are fantastic in their speed. And so if you think of it as the defender gets to move last, they're fantastic, right? They work very well to find arbitrary things, really. You can do them for code analysis. You can hook Ghidra or other sort of analysis tools up for malware analysis. All these things are fantastic. But when you consider that the attacker gets to move last, that means that they can discover the system. And we have successfully deployed multi-layer attacks through prompt injections, one of which targets the analysis engine, the agent that is meant to determine whether an attack is taking place, and one that is targeting the downstream system that is the actual target. So it's something to be aware of. That the flip side of that is they move at a speed that humans cannot. And so we need to continue that path. So I don't mean any of this to say that we should not have agents monitoring agents. It's just that we need to be aware of their limitations, particularly in the security.
Thank you very much. You said something very important, that all the agents monitoring other agents could be a positive development, but it needs to be addressed in a certain way, including from the security point of view. You also said something that we need to remember, that all the models are vulnerable. All the activities associated with the models could potentially be made vulnerable because of the speed, because of the autonomy, and because of other issues. Thank you very much. That's outstanding input. Matthew, you see the big picture as the CISO. What do you think is happening in the field? What are the most important issues?
Well, I look at it from a strategic view, right? So, and it really kind of comes down to three different vectors. The first, which is really kind of the largest growing risk, and that's the rapid adoption of AI systems, technology tools, without the necessary governance, oversight, or even response capabilities to manage the cyber risks that accompany them. So that would be the first one. The second one is really around the biggest threat vector itself. We all worry about the AI tools, and yeah, they definitely pose a risk. No argument there. But the biggest risk is actually with the legacy cloud and SaaS systems that we already use, that enterprise already rely upon, because they're beginning to open themselves up to be connected to these agentic AI systems. You know, as Jason was mentioning, right, you've got these agentic agents that are coming into these systems and creating, as a parent, creating child agents that are running amok. And organizations already rely on certain infrastructure, and we're exposing those in ways that we have no comprehension of, right? People are saying, hey, we love our tools, let's make them available. So let's create an API or an MCP, open it up to the agentic world. So that's actually the biggest threat, is the systems and data that we currently rely on to operate around the world. And then the third thing is really around the attackers, because we can never forget them. The attacker's greatest advantage is about automation. And again, Jason mentioned these agents and AI move at machine speed. So this enables attackers to be more effective and scalable in their attacks. So they can discover vulnerabilities faster. They can create exploits faster. And then they can use AI to orchestrate the attacks, right? Resulting in more significant impacts that are tougher to detect. They move too fast. It's really tough to contain and get in front of them. It essentially shrinks the attacker's kill chain, where they can find the vulnerability, develop the attack, go in, do tremendous damage, and now do that at scale, not just against one target, against multiple. So it changes. It's a dream for the attackers. And so that is their greatest advantage, is the automation capability across that entire chain. So we're in for some interesting times ahead.
Definitely interesting time, and maybe interesting times are not ahead, but with us already. You mentioned something very important, that the traditional cloud infrastructure combined with access to AI and agentic AI can be incredibly dangerous from the security point of view. It is also true that while all the large players talk about adopting AI, making it significant in their operations, there are also reports that are saying that most of it is just a vision, and for mission critical areas, AI is not used in most companies. From your vantage point, what do you see? Is AI really encroaching on the traditional infrastructure, or is it still limited?
So there's a tension in the system, because there is an undeniable rule that the value of AI systems are predicated on the access that they have to sensitive data and systems. So when the SAPs or the Salesforces of the world go, we need to enable our products so that customers' AI agentic systems can use this in so many different important ways, of course it's got to get to the customer's data. And so they're putting together, oh, well, we'll just make an API. Oh, no, that's not easy enough. Let's create an MCP to really enable these AI agents so they know exactly what they can do, so they can integrate even faster. So we're going to integrate and deploy these and give access even faster, knowing we don't have the governance, controls, oversight, or capability to manage the security risk. So it's a race that unfortunately security is losing, and we know it. That's why we're ringing the bells going, we need governance, we need governance, we need tools, we need capabilities.
Yeah.
This shadow AI, we're starting to talk about shadow AI because we don't even know what exists. So we're still in the early stages, but these large cloud and SaaS companies are way ahead of us going, hey, our competitors are opening their tools to AI. We want to make this. This looks great on marketing slides. Our customers are asking for it. It creates productivity and value. It's going to be in our quarterly statement. Yes, let's go fast. So yeah, it's going to connect with customers' data and systems and everything that's sensitive.
I know it will just the question is how soon. Marcel, you are looking at specific security issues, including artificial intelligence. What do you see in this field?
Yeah, so my background coming from system security means always looking very deep into the technology to understand what's going on. But also my role as an enterprise security architect, I have to look in the wider field and connecting it also organizational wide and understanding different angles of implications. And being part of an organization that's responsible for the digital transformation of a critical infrastructure, namely the energy network. Adoption of any kind of digital technology is important to explore. And AI, of course, is one of these technologies. And when we're looking at that, we have to be aware, of course, of the risk. And I think, Matthew said it, the adoption is very high and very quick, and let's do everything. So we need to be aware of what's going on. So as part of that, looking into that, but I must admit, I realized overall, it's nothing really new. So it's very similar things, that coming with AI, but they are amplified. So in the past, we had problems with SQL injection. Now we have prompt injection. The risk is similar. You have untrusted input, and something is going to happen because of that untrusted input as a reaction. The technical details, of course, are very different, because now we don't have any structured syntax that we can look for. We cannot look for specific symbols. Now it can be anything. It's language. That makes the problem harder. And so it goes with the other threats, I would say. So you have now agents, and they could have excessive access to things. That's the same topic we had several years ago, and when we said, hey, we need least permissions for our users. Because if you're working as root or super admin all the day, that's a big risk. And still we know our hardcore users are doing that or want to do that. And that's the same now with agents. So similar problems, but the details, the flavor is different. And that also means you need to know what are the new capabilities that you may need from AI security to build accordingly controls in that way. But also on the other hand, that comes on the organization aspect, is not only think about that, and you mentioned that governance is a topic Matthew raised, and I think that is also hard because at the end it's not only technology. It's the classical PowerPoint, PPT, people, process, and technology, so to say. The three items that come together, and you have to take also to look in the processes, because let's say you have identified all the things that you need to build, and maybe there are really great technologies that you can use, but who is operating them? Is it the same team that's operating the traditional security? Maybe yes. So IAM is a classical example, I would say. And now we have agents. We need to give them an identity, access control, but maybe other things like higher level up on the capabilities, where really you have more AI-specific topics. Would that fit to a classical role? Do we need new roles? So I think that is also something to keep in mind, not only the tech, but also the organizational aspects.
Thank you very much. It's important to remember that the underlying principles and approaches in security also apply to AI security, such as access control, such as data protection, such as defense against traditional attacks. But traditional users don't typically generate code. How do you address the issue that the operations of agents due to the ability to generate code, to generate prompts very quickly is somewhat different than traditional defenses we are using in the same field.
Right, that's a good point. And as also, I think it was Matthew or Jason, you stated that we have the scaling issue here. No? So it's scaling very fast. And also, I think it changes from static to more dynamic behavior. No? Things are changing very fast, and having static rules makes the problem different. But again, I would say some patterns are similar. So I remember very, very, very early days when there was the problem of having compilers on your PC. So if you introduce malicious code on your computer, they would basically download or compile executables on your computer and then would execute them. So one of the security strategies, and I think a lot of still have it in their policy rules, is don't have compilers on an ordinary business computer, where you maybe just use finance data or whatever. So they shouldn't have a compiler there. So we have to think about where we need this feature, where we need this capability. And then, basically think about the security that we would do if we have a normal development, software development. So what do we do there? And also, somewhere in the middle or in this timeline is low code, no code development, a topic that we had also a couple of years ago. No? So what do we do there? So now marketing, finance, or other non-developer people can, with a few clicks, create some automation, some basically software in a way. How to govern that and how to control what can affect that. And here now we have basically, again, the amplification of that topic. And I think it could be worth to have a look. And actually, that is also one thing we did is look how we deal with this low code, no code development. Can we apply the same principles, how we govern that, how we want to control that to the agentic? And I think that gives, at the end, it's a balancing thing. No? So you don't want to have a full-blown government process for someone who just builds a small agent that should sort your email inbox. If you would have to apply then for all the boards that you have in a large organization, it will take months. So you don't want that. On the other hand, you want the flexibility and the governance for maybe more complicated things. So finding the right balance, I think, is the biggest challenge here in introducing governance and security controls.
Absolutely. It's impossible to disagree with this. Everyone agrees also that AI leads to the increase in efficiency, be it through simple automation or much more complex features that can be implemented. As Chief Product Officer, Rupert, what do you see in this field, and how does security play into product development and related issues?
Yeah, from my perspective, there's a lot of great areas have been brought up so far. I sort of the big thing that's affecting me and my customers, we sell data and services around fraud use cases as well as security, and enable lots of platform providers and so on in the space. But when I sort of step back, my thought is, 6 months to a year from now, are any humans actually directly impacting with websites? And what does that mean for the world, right? So we've spent, 10 years with people thinking that they can tell, okay, yeah, there's some bots or maybe there's some automated users hitting my site, but most cases I'm building protections around humans. So, and these are not just, these AIs are not like traditional bots. Now they can have full control of my computer. So now the supply chain problems that we've started to see in the last, few years, where we've seen big attacks of my supply chain provider gets attacked, and then that allows someone to hack my system. You have to now think about that as, it's no longer just a two-party trust problem, right? So I'm a human, I'm trying to log into a site, I'm interacting with a site. Now I have an agent acting on my behalf. Can I trust my agent? Can the site trust the agent, the site itself, as was mentioned? is running its own, opening up its own systems through agents. So I'm now interacting with systems that make up that website that are agents, interacting with the core systems that that site has. So now I've got and then those could be third party, suppliers to, hosted SaaS providers who then could be getting attacked. So I have this really, really complex multi-party trust problem. And as we know, the more, parties involved, the more attack surfaces, the more complexity that has to be managed, governed, governance around all these types of things, trust. And the industry, obviously, it's not like these are new problems in certain ways, as Marcel mentioned, but we also now have to work at an amazing speed to come up with new standards and new ways to manage this in some sort of way that can be broadly, so Google alone is, and others, working with Google, like WebMCP just came out. That's going to totally change, how we now interact with web pages. And that's like the next step, but then there's a whole range of commerce standards that people are, talking about, AP2 and UCP and A2A and all these things. There's just endless standards are starting to emerge. How is I trying to do governance, as a CISO or something? How do I keep up with these standards? How do I make sure I'm implementing standards that are going to still be around in 6 months? How do all these standards, get tied together into a, holistic framework that we can actually think about this problem around? Everyone knows, I've been involved in many standards efforts and over the years, it takes years usually to develop these standards. And so how do we quickly build some standards so we can actually make some progress on this point? So.
Thank you. Thank you very much for introducing multi-party complex trust systems and standards. As you pointed out, standards take years to develop, whereas today models can update themselves and literally several new editions of the largest models are presented every year now. How do you reconcile the need for standards and the speed of development in AI?
Well, you don't, but I guess we would say, well, I'll apply AIs to help me write the standards, right? Which then raises this whole issue of can I actually trust the AIs? And I did want to make another point about AIs as users, and we're used to thinking about creating rules about how humans interact. And superficially, we can say agents or AIs are human-like 95% of the time, and then they quote hallucinate. But I would characterize hallucination as just an error, a statistical error that is very unhuman-like. It's not that AIs make mistakes more than humans, right? You can do all kinds of studies of humans. Do they give the correct answer in a chat situation to users, and 80%, 20%, 30, 40, 50% of the time they give the wrong support answer to somebody. Okay, so now I got an AI agent doing that, and it's wrong 5% of the time, and everyone freaks out. They're like, oh, it's 5% wrong. It's not that it's 5% wrong versus before I had 20% errors or 40% errors from humans. It's just that I kind of knew how humans made errors. And I built, we've built up systems for decades about like how I build processes for humans and what do I do when they make mistakes. Like the standard often is thinking through how are all the ways I can do something in a logical fashion. Well, now I got this statistical thing that I don't understand. There's new versions of the models come out every 3 months. The model now behaves completely differently from how the old one did. I built all kinds of QA and logic to protect myself against the ways that it messed up that I'd never understood. And a lot of the security research is like, how do I figure out ways that AIs are going to do things that are so unhuman-like when they mess up, right? So,
yeah, that's a very nuanced, excellent answer to this question. Many years ago, actually, I think 10, an academic collaborator and I introduced the idea of writing some of the standards with artificial intelligence, the automatic parts where you do references, prior art, and things of this nature, and also check consistency with artificial intelligence. It wasn't well received in the ISO. Well, simply because it undermines the consensus system that it is based on. But I think it will happen. You brought on a very interesting area. We need to understand how, from the human point of view, because ultimately humans design the rules and the principles of the systems. We need to understand why certain advice is given, why certain risks arise, and so on. This is called by non-technical people explainability or transparency. How do you think, Martin, the desire explainability affects security? Is it positive? Is it negative? Is it neutral? Is it important?
Explainability is an interesting concept because
Yes.
it's a very human concept. So we expect to take things, as Rupert was just saying, that are actually divergent from the way humans behave and explain them in human terms. I think explainability is critical. We build all of our controls out of understanding. So what is the difference between good software and bad software? Well, there's something that you've done to explain that good software is good and something about bad software is bad. And I think that explainability technologies, if you think about them from the perspective like the research angle or the technical angle for AI, it's hot. I was at the NeurIPS conference in December, which is the largest AI conference in the world, and there's whole workshops dedicated to just explainability techniques. But the thing that comes out is you gotta be careful what they're explaining. What is it that they're explaining? We all want something kind of like a courtroom where you sit the AI down and put it under oath and make it explain its prior actions. But they don't work that way. They don't remember. They don't understand themselves why they hallucinate. They don't even know that they're hallucinating, or maybe they do. That's one of the things that's coming out of the explainability research. So there may be some promise there, but ultimately, most of the explainability techniques are just another way to sample the internals of the model. And that's also how the output is generated. And so the explanation itself can be misleading. I'll give you an example. There's a lot of focus right now on using the reasoning traces. So models that have reasoning capabilities where they can think about what they're going to say before they actually say it, using those reasoning traces as a kind of explainability metric. But the data shows that those can be manipulated and fooled, or even the model itself might manipulate it in order to get, kind of its reward. Such that the actual output has nothing to do with the reasoning trace. There's no technical reason to believe that it is actually producing an explanation that matters. So I think they're very valid. They're very good for researchers, but you need to cap that with an understanding of the limitations of the explainability techniques. And then that's just at the very low technical level. Then most people don't care about that. They really want an explanation of why did the agent do this thing? It deleted all my files. Why did it do that? Well, that's like a much higher level of explainability that goes well beyond understanding why the individual layers in the neural network that composes the model produce the particular outputs that they did.
That's an excellent example. I always find it daunting that the expectation is for true reasoning and solid explanations from statistical next token prediction systems. It certainly is an expectation that cannot be true, at least with the current level of technology. Rod, what do you think?
There is actually a
Go
really
ahead.
simple answer, which is if you
Yes.
want to know why the model does what it does, look at the data that it was trained on. That's the actual answer. It was trained on a set of data. So why does my model sound like Reddit? Well, because it was trained on Reddit data. That's why. So there's kind of that overly simplistic answer as well. Go back and look at the data.
Right. But this is sort of answering a different question, because the expectation is that you understand the reasoning, right? Not that you get exposed to data. But that's an excellent point. The model is as good as the data. It's used for training. Its approach is related very, very closely to the data used for training and retraining. Excellent point. Rod, what do you think about explainability? Is it achievable? Is it important for security?
Yeah, it's a great question. And probably, unfortunately, I don't have as much experience as Jason has in this area. But what I've been focused on, and a couple different things, came to mind as he was speaking. As I and a lot of developers spin up swarms, you give them you give them certain access to do things, and segmenting that access like per MCP server to perform specific tasks gives me the ability to segment, what they do. Even the orchestrator or the swarm owner, you could call it the queen, whatever. There's a lot of different terminology there. As a visibility point to where different things are pulled in from some type of activity. I think one of the other things I've heard is leveraging OpenRouter. Or there's some other, basically, you want to perform some type of search, some research, whatever that is, and you leverage one of those capabilities to where it looks at the major frontier models, queries all of them to the same the same way, and comes back, and it can serve as somewhat of a traffic cop, and determinator. But still, I think, again, as Martin, articulated, when it comes to these frontier models, there's going to be layers of obfuscation that we're not, probably just not going to be able to do. I think as we look forward and we're able to run more local models specific, not on the monolith approach, but to specific areas of interest. I do think that it'll be, more and more feasible to do, and those obviously will have, training. We'll have, the ability to dictate the training, the ingestion, the all the different particular things as it relates to that, the inference. So it's an area that probably, unfortunately for security, there's a lot of other things for me to focus on first, and some of we'll get to that at a later point. I'll leave that to Jason to figure that out.
Thank you. And Rupert, would you like to make a couple of final comments on explainability as we move to the next topic?
Yeah, I mean, I think as you mentioned, we're used to explainability being like a 0-1 sort of yes/no situation. I can directly tell. And these models are statistical, right? And so, there are no true proofs in social sciences, and there won't be in AI models either. So from an explainability perspective, the system is so complicated and so sophisticated. And the foundation models from big providers they don't tell us what techniques they're even using, right? So it's one thing to say like, yeah, an LLM by itself might have the types of ways of being explainable, but now I'm applying sophisticated reasoning models on top, right? And a human, again, these models are also trained to to please the user, and thus they have a tendency to be overconfident, to try to say what they think you want to hear and all that kind of stuff, right? So I only see that sort of problem getting worse. And as was mentioned, you can look at the thought chains, and there's been research already showing that the models, let alone are lying, but even if they're even understanding their own thought chain. So the best approach at this point seems to be around boxing of steps, as Roderick was sort of saying. I break down, this agent only can do these things, and it has very specific outputs that it's allowed to think about. And so from a swarm perspective, I can solve a problem by having a bunch of very constrained models in what they can actually do and what they can think about. And that's how I kind of get some explainability.
Excellent point. Attempting to box agents, prompts, other components of the specific AI applications is bound to reduce the risk somewhat, at least temporarily. Thank you very much. AI systems today are intrinsically connected with automatic code generation in a variety of ways. Code generation, of course, for AI systems themselves, but also code generation for other systems. It was pointed out that there are significant security concerns associated with this, both for AI systems and outside of AI systems. Marcel, what do you think about this? Do you think it's a serious issue? How can it be addressed? You already said something in relation to this topic when you talked about compilers.
Right. Yeah. So basically, at that time, we shouldn't have compilers on an ordinary computer, but you cannot really say you shouldn't have agents on today's computer. So it might be difficult. And when it comes to code generation or AI-assisted code generation, I would again say similar risks like you would manually write code, yeah, but again amplified, that it could be insecure. There were studies that they generate a lot of insecure code because they were trained basically from whatever Stack Overflow, Reddit, and etc., where also a lot of insecure and wrong code exists besides good code. So how can you distinguish that? And how can you distinguish that if a person writes bad code or good code? So same question, but amplified because you can do more in less time. So for me, that means basically first, and similar to what one in the beginning said, you need to have your basics right. So a lot of things was mentioned about cloud security and this, and I think here also the basics should be right. So if you don't have a good AppSec process, AppSec system, AppSec toolchain, etc., now is the best time to ramp it up because AI will just again amplify the problem. So in the same way, we could start to use the tools that we have there. So any software application security testing, static or dynamic. So AI generated code should be inserted to that. We should have build pipelines with guardrails. And I think also the sandboxing topic is a good idea. On the one hand, to give these coding agents not too much access to everything, so that they cannot delete your entire source code repository, for example. So there were techniques like give it a separate branch from your repository on a containerized environment, so isolation techniques to use that, but also have the agents work with their own identity. So if they check in code that you see, oh, this code was checked in by AI and not by a user, or it was supported by AI and then check them by user, because then if you want to look which code has been touched by AI, it makes it easier to go through your repository to see, okay, this was all touched by AI. And then maybe if we have better tools to scan that or to analyze that, you can direct it there. And so that's more the technology part, but I think there's also a design part. So test-driven development or specification-driven development. There were things in the past where people tried it out and then they left it. Like, oh, it's hard work to do, and it's in principle a good idea, but then people don't do it. But now we have AI, lazy people doing the work. Yeah, give the AI the job. So I have seen that people using them to design the test, write the tests for themselves. The agent is writing the test for themselves, or one agent for another, and also clearly specify what you want to do. I think that could be maybe even a chance to improve code quality overall, because the more AI you use, the more precise you have to be on your requirements. And if you think about in the past, who likes to write long requirements documents? In the past, no one did that. Everyone wants to write the code. But now AI is doing the code. You have to write a good requirement specification. Maybe here's a chance that overall we have a better improvement.
Outstanding comment. Now that AI is writing the code, we need to learn how to write more specific requirements, and it certainly can help. What do you think, Matthew? Do you think that on balance, AI can help defenders at least as much as it helps attackers, and it can correct mistakes at least as much as it generates mistakes? Or do you think we are not yet there?
Yes, and to build on what Marcel said, because again, he's talking about some very important things. We need to apply the same practices that we have in the past. And when we're talking about attestation of who's doing the code and change control and all that, that's important. The other thing is to understand from a security perspective, specifically a cybersecurity perspective, we only care about certain kind of vulnerabilities that can be exploited to do bad things. If it's vulnerability in AI code that messes with the functionality that's not going to represent a risk to the confidentiality, availability, or integrity of that system or adjacent systems, that's a code problem, right? That's a bug. Yeah, it's a potential, but we tend to narrow down what we're looking at. And so if that's the case, we need to focus on vulnerabilities that will be discovered, that will be exploited because they represent a risk. We're not worried about all vulnerabilities. So we need to look at what the attackers are using, and they're using AI tools to discover vulnerabilities so that they can exploit. We can use the very same tools, and we need to. And this is not unusual. This is what's been happening in our industry forever. Whatever the attackers are using for tools, we're using for defense. Whatever we use for defense, they use for offense. So the same principle applies. We need to understand what the attackers are using, what they're going to go after, what they're going to find, get in ahead of them so that we can fix those vulnerabilities. And unfortunately, we're not here to fix every single vulnerability, right? We won't. There will always be more that are discovered later on. That's fine. But we need to focus our energies to be the most efficient and effective to be able to blunt the bad things that we're trying to avoid. So we need to keep the goal in mind. It's not perfection. We know there's going to be errors, whether it's a human or whether it's an AI that is developing code, products, tools, or processes. We need to apply our basic fundamentals in security and focusing and optimizing what we do to deliver the right outcomes.
Thank you. That's an impassioned and an excellent view on the topic. As our final question, and based on a question from the audience, let's make our conclusions about the future of AI security. And from a positive point of view, how do you think AI security, AI in general, can protect systems from cybersecurity attacks? And we'll go in reverse alphabetical order of the last name now. Rupert, what do you think? what are the positives of having artificial intelligence? How can it protect systems?
Yeah, I mean, I think as Marcel and Matthew just were saying, we can do a lot of things that humans don't want to do. We can have much better documentation specification. We can have 15 different models test our code and point out insecurities, right? So, when the newest version of Claude came out, they said, "Oh, we found 500, exploitable issues in major open source projects. We just threw our latest model at it, right? So we can all do that so much more than we've done before. The speed that we can test things. I'm struck by defense in depth is a long-standing sort of set of techniques that people do, right? We can do prove our code actually does what it does for the code that really matters. And again, that's been too expensive in the past. Now we can speed those sorts of processes up. There in the last 10 years, we've gone from being able to prove things that used 10, 20, 50 lines of code. Now we can do millions of lines of code. So then I can prove the code can only do what it actually does, right? So even the top open source projects that have been reviewed by millions of people, for decades, still are estimated to have, tens to hundreds of exploitable bugs per million lines of code. We can actually try to tackle those things and remove in a provable way all open doors, right? And we can run more sophisticated operating systems that have been designed in that total security, and so I can have true isolation of things. So there's some interesting things that can be done in that fashion.
Thank you. So automation is difficult for defenders, but it's also great for defenders looking at it from various other vantage points. Thank you very much. What do you think, Marcel?
I think if you would say, hey, here are 10 or 12 AI security capabilities, and I would have to pick one, I would say it's all about visibility. Understand what do you have? Where are your AI assets? What kind of data they are accessing? The output, where is it used? How are things connected? If you have that visibility, you can, on the one hand, beforehand, analyze, is that a risky architecture? Is that a risky design? Could something happen? Yeah. And also, even later, if something happened after the facts, it gives you the possibility to analyze, okay, how did that happen because of this chain of events, this chain of things. But if you don't have that, you have really a big problem. And I think a key here is that we have a lot of frameworks. We have a lot of ways how to build AI systems. It starts with the foundational models. Then we have agentic frameworks, and we have different cloud environments. I think in a small organization, you just probably pick one and build your stack from there. But in large organizations where I work, for example, you have multiple of different business units, product groups, and areas. And at the end, you have different frameworks that you use, different cloud environments that you use, different approaches that you use. So you need, at the end, but one way how to identify where things are and how they are connected. So that's, I would say, the foundation. Anything else, of course, if you only have that, it doesn't work as well. You need additional things on top. But if you don't have this visibility, everything else will fail, I would say. So that's a key thing.
Absolutely, the key thing. And this is sort of the security practitioner's dream for 20 years and more. We were talking about how to understand the security models and their connections in various frameworks. Now we can do it automatically, and hopefully we can also do it correctly. Thank you very much, Marcel. Matthew, what do you think?
So you want a positive twist on this.
Yes.
Positively, we don't actually know. But in reality, right, AI is amazing and powerful tools. And it's really tools. The attackers are using them, and we will, as defenders, also use those same tools. But there's a window of opportunity. And the attackers get to haphazardly use these tools because they don't care if things break. So they get this head start to be able to use these tools to automate things, to be more effective, to scale, to all these great things on their behalf, right? Not so good for us. And we have to wait. We have to wait until there are more mature and tested tools on the security side because we can't use an untested tool. It may do more harm than good. So there is this window, this lag, but we will get there. Probably right around Q3, we're going to see across the industry, across every single security vendor, advanced AI tools that are actually effective. And that will have a compounding effect to counter what the attackers are doing. So last year it was in the marketing slides, right? AI security tools, right? It's vaporware. But this year it'll actually manifest. But there is that lag. So we have to suffer, right? Advantage right now is the attackers, but we will catch up. This is the nature of the tension in the system between attackers and defenders. They just get a head start. So, don't give up, right? We need to keep pushing forward and look to use and leverage AI to counter the AI threats.
Thank you very much, Matthew. That's a realistic view. They certainly do have a head start, but we can, at least in theory, have useful tools to minimize this head start and make things more manageable. Hopefully, it will come to fruition. Jason, what do you think?
Yeah, I mean, I think I agree with Matt in particular. I think it's important to take a step back out of all these risks and remember the value creation that is happening with these tools. Processes built around Excel spreadsheets are getting accelerated so they get done in a day instead of a month. Like data is being transformed into more usable formats. Unstructured documents that have existed for 50 years are being turned into structured insights. Like there's very good things that are coming out of AI, and really risk is managed at a level above just cybersecurity, right? And you see a lot of companies pushing AI because their board has decided the opportunity cost of not participating in AI is higher than the cybersecurity risk of participating in AI. So there is a certain element of that. But also, the tools, as Matt said, are very powerful, and we can accelerate and move the cybersecurity space as well with all of those tools. We use AI coding tools in my company all the time, and I'm at like 100 times faster than I was before. Like that's a positive thing that enables a lot of value creation, and it enables responding to this new sort of speed of things, where the human is managing, I think, a swarm. I joke with my wife. My job now is tending a herd of bots that are working on 10 problems at once, whereas I would spend a week working on one problem before. So I think that there's a positive spin to that. And then I can't leave without saying, well, my company's existence, the purpose of our company is to protect AI systems. That is what we do. And I'm not a salesperson. You won't get a sales pitch from me, but we do supply chain, runtime, and red teaming sort of products.
Thank you. Thank you very much. And this is what I observe also. There is a lag because of the eagerness of using or attempting to use AI tools for everything. But there is also an opportunity because all of us can do things faster, see a bigger picture, see it sooner because of AI tools, imperfect as they are in cybersecurity today. And Rod, you get the final word. What do you think?
Yeah, I think I'm probably a little bit more bullish. I think, from my vantage point, and working with there's a couple of tools I use that, as I spin up a swarm and it starts coding, I see CVEs pop up of what's happening there. I get to the end of a certain run, have it say, go fix all the vols. It comes back, this last night, hey, fixed 18. I'm seeing more and more. I think we're going to see the emergence of a marketplace to where there's a lot of people, you've had these, different open source things. I think we're going to see a lot more tooling come to a marketplace like this where I can use, I can run 15 different open source scanners on my code in a safe environment and have a pretty good assurance that it's not nothing, it's clean. The other interesting thing is look at, different organizations as they mature. There's some things that, always get pushed to the back priority or not prioritized. Like, DR BCP seems to be one of those. But, few companies, or I'd say not all, do red teaming. So there's red teaming, I've seen, GitHub red teaming. So that's been a pretty high bar in the past. It's a certain, expertise level and skill set. Now you can run that on your own. You can be very detailed in how you customize it to your environment, what you put as your, rules of engagement, pull in your blue team, your even audit in that process and build a lot more visibility into that in real time than was ever possible before. So I think, and again, to Matt, like, Matt's key point earlier, it's a race, like, the bad guys out there, the nation states, they're going to be doing this. We kind of don't have a choice. Like, we have to do it now, do it safely. But if you feel a little uncomfortable out of your comfort zone, it's probably good in a safe way doing some of these things, because I think organizations aren't going to have a choice. I think we're still in a little bit of a, what's that, immature, like on a hype curve or anything like that. We're still on the ramp up there on what we're going to see. We're going to see a lot more, and I see a lot of tools that could also be dual use, as Matt said, like, hey, here's a great protection. And I've even heard, one of the creators say, don't do this, or he's like, you could, turn this around and create havoc for people. So I think, the Wild West is probably going to get a little bit more wild before, some where organizations are pushed to take on some very different approaches there. But so I'm optimistic, but still all I been in the field too long to know that there's no panacea, and usually the bad guys beat us to the punch first. And so there's always been promises from the firewall is going to fix it, AV is going to fix it. It's never fixed it. So it's again, defense in depth and leveraging a lot of the fundamentals we have, but then also building into organizations the security mindset of we have to test. We have to put not only our security team in the traditional sense of we have to enable them to go test with the cutting edge tools, just like everybody else, so that they can protect us the best possible.
Thank you. Thank you very much. So we highlighted the problems, but we ended on the note of cautious optimism, or at least potential for cautious optimism in the future. This is an enormous topic. We could have discussed it for hours and days, and I'm sure we will return to this topic in the next weeks and months. Rupert, Marcel, Matthew, Jason, Rod, thank you very much for joining us today. It's a lot of food for thought for our synchronous and asynchronous listeners and viewers. Thank you very much for the audience who joined us today to listen to this, and thank you to Trust in Digital Life for organizing this series and for hosting us. With that, I pass it on to David to close.
All right, thank you very much, Claire, and thank you, panelists. A fascinating discussion. I'm thrilled and delighted that we finished on an optimistic but cautious note, and it's a segue for, as we were saying before the session started, we've got enough material here for plenty more sessions in the coming months when the landscape changes yet again. So thanks very much, and thanks to the audience for sticking with us. We did go over time by 10 minutes, but that's just an indication of the discussion and the material that we were talking about. So there will be a recording and a summary report available shortly, which will be made available to everyone to enjoy and distribute. And with that, I wish you all a good morning, a good afternoon, and a good evening, depending on where you are. Thanks a lot.